Hi guys, so in this video we're going to be going over vectors. This is one of the slightly harder concepts in the AdMath course, but I'm going to start off with the foundational concepts regarding it and then move on to harder problems. So in science class you might have heard about scalar quantities and vector quantities. And the main distinguishing factor is while scalar quantities measure only magnitude, vector quantities measure both magnitude and direction. So what that means is that even though these two values have the same magnitude, the direction is different and therefore the vector is different. And it will have the same scalar quantity though. So if you take a look at the left example I've drawn over here with 3 and 4. So we can see that it moves 3 units to the right and 4 units up. And based on that, if we use Pythagorean theorem, we can actually get the magnitude, 3 squared plus 4 squared, which gives us root 25, which is 5. Therefore, the magnitude of this line is 5. However, it's a vector, so therefore we have to consider direction. And based on this, we can say it's moving 3 to the right and 4 up. Now, it's important to recognize that the magnitude would be the same if we move 3 to the left and 4 up, or 3 to the left and 4 down, or 3 to the right and 4 down. All these quantities are the same. So what we need to do is acknowledge this moving to the right and up specifically. And to do that, we use I and j. These are unit vectors that represent set quantities that we will always use in vectors. So I represents 1, 0, which means 1 unit to the right and 0 units up. J, on the other hand, is the opposite, which is 0, 1. It's 1 unit up, but nothing to the right. And combining these unit vectors, we can express this vector. So because it moves 3 units to the right, we represent as 3i, and it moves 4 up, so it's 4j. So unit vectors are basically vectors that have a magnitude of 1, like I and j. I and j are the most useful, but we can make every vector a unit vector while still maintaining the same direction. So for example, if we wanted to move 3 to the right and 4 up and still maintain that direction, we can change the magnitude so that it becomes 1, but the direction remains the same. And the way we do that is we take the vector, so in this case it's 3i plus 4j, and we divide it by its magnitude. And its magnitude in this case is 5. So therefore our unitized vector, I'd like to say unitized, is 3 over 5i plus 4 over 5j. So it moves 3 over 5 to the right and 4 over 5 to the top. And the reason why it has the same direction is because the ratio of the I and j values is the same. And therefore, even though the magnitude itself has gone down, it's been changed by the same amount, and therefore the ratio is maintained. All right, so now it's time to look at the diagram on the right, which explores some of the relationship between some vectors. So because vectors have directions, it is important to recognize that this line over here can be PQ or QP. In this case, we're going to do PQ, acknowledging that's going from P to Q. If it was QP, it'd be going from Q to P, and that's different. So in this case, we can tell, it's also important to recognize that going from O, in this case, B, which is one of the vectors, represents OQ. And it doesn't matter how we get to OQ as long as we add up the vectors along the way. What I mean by that is that B is equal to A plus PQ, because in A plus PQ, you're going from O to P and then P to Q, which is the same as going directly from O to Q. And that's one of the relationships. You add up the vectors if they lead onto each other. It's like a path you're following. Therefore, we can rearrange to find PQ is equal to B minus A, which is not immediately evident from this diagram. Therefore, it's important to write out these relationships and then rearrange accordingly. So I think these are just some of the basic parts about vectors, and now I'm going to move on to a practice problem. So the figure shows points A, B, and C with position vectors A, B, and C respectively relative to an origin O. The point P lies on AB such that AP to AB is 3 to 4. The point Q lies on OC such that OQ to QC is 2 to 3. Express AP in terms of A and B, and hence show that OP is equal to 1 over 4 times A plus 3B. All right, so I just drew some rough work over here, but we're going to start this off. So what we will first do is recognize that AP is this direction over here, and it lies on AB. So it's told us that the ratios are 3 to 4, which means AP is 3 to 4 relative to the entire line. Therefore, AP we can say is 3/4 of the entire line. Now, what we can do based on this ratio, we can actually find what AB is and then multiply that value by 3/4 because we have B and A connected by AB. So we're going to write out that relationship. So just as we had above, it's B is equal to A plus AB. Because if you follow the line, it still leads to OB. And OB is represented by B. Rearranging, we get AB is equal to B minus A. And now we can multiply this by 3/4 to get AP. So 3/4 AB is equal to AP, which is equal to 3/4 B minus 3/4 A. And now what we want to do is answer the question which says, hence show that OP is 1/4 times A plus 3B. So OP, I'm just going to draw a line connecting O to B. And now we can figure out the path to get there. So we know OA is A and AP is 3/4 B minus 3/4 A. And we can actually combine those. So this is OP over here. If we follow the path, OP is equal to A plus AP. And if we substitute what AP is, we get is equal to A plus 3/4 B minus 3/4 A. A minus 3/4 A is the same as 1/4 A, and then 3/4 B remains. And if we factor out the 1/4, we get 1/4 A plus 3B. And that's as required. Sorry, I don't know why I did it over here. I'm just going to box this and move it up. All right, now let's do the actual question I was writing under. Find PQ in terms of A, B, and C. So PQ is this line over here. And what we can do is, first, we know that OC is broken up into specific ratios. It's broken up, so OQ is 2 and QC is 3. Since 2 and 3 add up to 5, we can represent it as fractions of the entire thing based on that. So OQ will be 2/5 because it's 2/5 of the entire thing, while QC is the other 3/5. So based on this, we can say that PQ, I'm going to write it as QP actually because it's just easier to visualize first. So QP is when it goes from Q to P. So QP is equal to it's equal to QO minus plus OP. And now we can substitute values in. So QO is actually negative 2/5C since we're going backwards on the lines OC, making this negative C. So it's negative 2/5C plus OP, which is going towards P, and that gives us OP we know is just B. So it's negative 2/5 C. Oh, sorry, it's not B. It's OP is 1/4 A plus 3B. So it's plus 1/4 A plus 3/4 B. So that's what QP is. However, it's also worth acknowledging that we're looking at PQ. So that's equal to 2/5C minus 1/4 A minus 3/4 B. Let me box that. Sorry, I forgot to box the right answer. That's our answer. And it says, given that 5PQ is equal to 6BC, find C in terms of A and B. So BC, we can tell based on this. So we know BC. So I'm going to write this as CB first. So CB plus OC is equal to OB. So if we rearrange for CB, we get CB is equal to OB minus OC. And what that means is that BC is equal to, so first we have to figure out what OB is. So OB we know is B. And then OC is equal to C. So it's b minus c. Therefore, BC is the negative of that, negative b minus c, which is equal to c minus b. So based on that, we already know what PQ is. So we can say 5PQ, so 5 times 2 over 5 minus 1 over 4A minus 3 over 4B, which we had gotten in the previous part, is equal to 6BC. So that's 6 times C minus B. And if we expand this, we get, the 2 over 5C. So we get 2C minus 5 over 4A minus 15 over 4B is equal to 6C minus 6B. And if we rearrange, we get 4C is equal to negative 5 over 4A minus 15 over 4B plus 6B. So that would be plus 9 over 4B. And we can just divide both sides by 4 to get C is equal to negative 5 over 16A plus 9 over 16B. And that's our final answer. So in these ways, we just tackle this problem using the diagram. It's always good to annotate the diagram and try and visualize the situation a bit better. Always construct triangles and follow the path is my advice. So thanks so much for watching, and in the next few videos, we'll probably go into some more complex problems with vectors, but until then, goodbye for now.